Okay, lesson 7. Unit circle, center line, amplitude, phase angle of sinusoids, which are the sine and cosine graphs, period of a function, important numbers, exponential functions.
That's a lot.
It is a lot thrown into one. So, let's get a move on, right? Okay, unit circle. That first little picture there, just kind of reminding you, on a unit circle, first of all, the angle always goes up from the x-axis, right? And a point on the unit circle, the ordered pair is xy, of course, but remember, x represents cosine and y represents sine. So the whole idea that in an ordered pair, it is cosine sine. Okay? Do you guys remember graphing sine and cosine graphs last year? Sine and cosine, they both have a period of 2 pi. So they both go, a phase goes from 0 to 2 pi. They both have a range of -1 to 1. They go as low as -1, as high as 1. Sine starts at 0, 0, 0 that is, maxes over pi over 2, has another 0 at pi, a minimum at 3 pi over 2, and another 0 at 2 pi, right? So it's crossing through the x-axis every pi. Cosine, it's a phase shift of it, right? Take your sine graph and shift it left, and you've got a cosine graph. So cosine, the difference is it starts with a max at 1, crosses through at pi over 2, minimum under pi, is 0 or crosses through at 3 pi over 2, and maxes at 2 pi. It's still crossing through every 1 pi. Okay, so those sound familiar, right? Because we're going to graph some today. Let's look at example 7.1. Shown is a unit circle centered at the origin. Find the coordinates of P1 and P2. So, if you recall from the very first day of school when I had you filling in those unit circles, right? You were filling in the ordered pairs also. And we talked about ways to get those and everything. So, for P1, notice what is that reference angle? That reference angle is pi over 3. So you can either think pi over 3, or if you prefer, you can think 60 degrees, right? So what does the ordered pair for P1 look like? The x-coordinate is going to be what? Yes. Okay. So your x is the cosine of pi over 3, and the cosine of pi over 3 is 1/2. So your x-coordinate is 1/2. Your y-coordinate is the sine of pi over 3, and the sine of pi over 3 is square root of 3 over 2. So the ordered pair for P1 is 1/2 comma square root of 3 over 2. Easy enough? Okay. Now, P2. What they tell you is it is an angle of -135 degrees. We need to talk reference angle here. What is the reference angle for P2? 45? Because the difference between 135 and 180 is 45, right? So this right here is 45 degrees. So you can either think 45 degrees or you can think pi over 4. I mean, if you want, you can also think that P over 2, 360 minus 135. I mean, this is located at 225 if you want to think that way as well. Okay, but honestly, 45 is what I need. Okay, what about this ordered pair for P2? We want to do the cosine of pi over 4 and the sine of pi over 4. What do you know about the cosine of pi over 4 and the sine of pi over 4? About the same. Square root of 2 over 2. So, what do you have to think about now?
And they're in the tangent section.
Okay, so they are both negative. You can think because they're in the tangent quadrant, all students take, so tangent's positive, sine and cosine are negative. You can also think, okay, if you're graphing, how do you get to this quadrant? You go left, which is negative, and you go down, which is negative. So that makes both an x and a y coordinate negative. So for one reason or another, can you come up with that? Okay. Questions? I don't know if that's super easy, but yet it's becoming old news. Okay, at some point last year, we graphed all these lovely friends. Centerline, amplitude, phase angle. Okay, the graph of sine and cosine are both considered sinusoids because they look the same. Now, I can't remember if the lettering is exactly the same as the pre-cal book, but the format there, it's not now that I think about it. They have y equals a plus b sine of theta minus c, and the same thing for the cosine. What can you identify about a, b, and d? Remember what any of those do?
Okay, I know that B isn't that. Is that amplitude? Is that control? How high and low it goes?
Yep. B is your amplitude. So, or in other words, obviously what's really better to remember is just the number that multiplies by the sine or cosine function. Okay? You obviously can't just remember letters because they might change. But I'm going to... Yeah. So he used amplitude and he said how high or low it goes. I'm also going to say, I like how high and low it goes. I'm also going to say distance from center line. Because it, helps us adjust our center line there, doesn't it? Okay.
Oh, isn't that what it is?
Ah, there we go. Yep. So, A is your center line. Now, I believe last year in the pre-cal book, it was at the end, wasn't it?
Yeah.
I don't think it was even A. I honestly don't remember what it was. I wish I could tell you, but okay. Last year in the pre-cal book, the number add or subtract at the end was your phase shift, I think. Or your center line. Now they have it at the front. The idea is a number added or subtracted away from sine or cosine is your center line. It is your y value of the horizontal. I guess I don't want to say, I'll say center line. And then Ross mentioned earlier for D, he said the phase shift. I have phase angle written down here. I think it'd be the same idea. Okay. Phase shift or angle, if you would. And that does move the graph left to right. Okay. So now is to remember how to graph these by hand. Okay, to have a good idea of how to graph these by hand. So when you're ready, start looking at example 2 there. Is it coming back to you? Maybe coming back to you didn't care for these, but We did a quiz over them. I think we did the quiz over them, didn't we? Or did I skip the quiz? Okay. I think it was the I think there's previous year I had to skip the quiz for some reason. But most people it wasn't too bad. Occasionally people struggle with this, but okay. What can you tell me on this graph here? Okay. Center line. is at -3. What else? Okay. Has an amplitude of 5. And what about the phase angle or phase shift? It's 45 degrees, which is the same as pi/4. And remember, I don't know if she did on purpose or just said it, but it is a positive 45 degrees. That's in parentheses, so you're going opposite the direction of the sign, yes? Okay. Well, if you recall, I usually set this up as a vertical axis and a big, long horizontal axis. Okay. My central line is at -3. So I'm going to put my horizontal axis at -3. My amplitude tells me how high and low to go. So I'm going 5 up and 5 down. 5 up takes me to 2. 5 down takes me to -8. Okay. When we graph this, if we're just doing a period of, oh wait, what kind of graph are we graphing? Cosine. Good to know, right? A period of cosine is 2 pi. So I tend to, and I don't know, everyone does this their own way. I tend to say, okay, there's 2 pi. In the middle of 2 pi is pi. In the middle of my pi's are pi over 2 and 3 pi over what? 2. Okay. And now, in a traditional graph, I'm going to grab a pencil here. Before we do the phase shift, what's a cosine curve do? Starts at the top, cuts through the first one, a minimum at the second, cuts through the third, and a max at the final. Does that sound familiar? Except no reflected. The negative would be on the 5 if it was reflected.
See, I'm used to that from last
Yep,
year.
I see where you're, yeah.
But so we need to phase shift it.
Yep. So 45 over pi over 4 over, which means, what do I really need to do here? Yeah. Right here we have halves. So fourths are just going to be the mark in between, right? So pi over 4, pi over 2, if you just put in a mark in the middle of each section, that would work because 1/4, 1/2, this would be 3/4. Then you have 1 pi. You would have 5/4. 3 pi over 2 would be your 6/4. And you would have 7/4. I guess we said we were going right, didn't we? Well, then I better put 1 to the right of 2 pi, which that would be 8 pi over 4, so 9 pi over 4, if you will. Okay, so basically each of those marks I had put on earlier, move them 1 tick mark right, yes? So instead of starting up here at 0,2, start above pi over 4. Instead of cutting through at pi over 2, cut through at 3 pi over 4. A minimum below 5 pi over 4, cut through at 7 pi over 4. I'm going to end at 9 pi over 4. Remember, to the best of your ability, these are rounded, not pointy. But I don't sometimes fail too, but you know. Okay, coming back to us gradually. Okay. Example 3. And as I said, I am skipping some of these examples. We're not going to do all of them just because we don't really have time. There's a lot. Bless you. Okay, example 3. Practice a little bit with this one. Get some of the basics. Let's see. What about the center line? -3. Again. What about the amplitude? 4, and because the negative's on the amplitude, so basically the negative's on the sine or cosine function, we're going to reflect. And when we talk about this reflect, it's going to be reflecting over the x-axis, so upside down. Phase angle. -45 degrees, which is like saying -pi/4. And yes, we are going to be shifting to the left. Okay, I'm guessing you have the basics at this point. Do recall also that this is a sine graph. So let's see, center line of -3. Labeling up 4 to +1. Labeling down 4 to -7. I'm going to do the same thing as last time, and I'm going out to 2 pi. The middle of 0 and 2 pi is 1 pi. The middles of those are pi/2 and 3 pi/2. Now, I don't know where you're at on this kind of stuff. If you need to, you can go ahead and sketch the sine curve right now. If I go ahead and sketch the sine curve before I put in the extra tick marks and everything, what's going on here? It's sine, which normally starts at 0, 0 goes up, then down. But we're reflecting, so we're going to go down, cross through, and then go up. Okay. Now, if you haven't already done it though, you need to do the phase shift. This time we're going left, so you're still putting your pi/4 marks in, but you need to make sure that you put one to the left of the y. So -pi/4, there's +pi/4. So 1/4, 1/2, 3/4, 1, 5/4, that's 6/4, 7/4. So, start at -pi/4. This time, instead of my minimum being under pi/2, my minimum is going to be under pi/4. Cross at 3 pi/4. Max above 5 pi/4. Cross at 7 pi/4. I don't know why I feel like that one's like lopsided or something, but okay. when you get to the backside, in an effort to move us along, so example 7.4 is another one. And example 7.5 says to, use the calculator to draw. I'm going to jump down to, and who knows, I can't believe we'd actually have extra time at the end, but, again, want to make sure we get through everything. Can I jump down to C where we need to talk about the period and how it changes? Because notice none of those, the phase shift was right there. You didn't have to talk about a number or anything out front. So let's jump down to example 7.6. So the period of the function is how often the function repeats itself. And our periods we were working with were 2 pi, right? We like it when the period is just 2 pi. However, realistically, that's not always the case. So, sine, cosine functions normally have a period of 2 pi. The difference is when there's a number in front of theta. Okay, that's when we have a difference. Now, the way this is set up, notice it's c times theta minus d. C times theta minus d. In order to find your period, you take that, basically that coefficient, and divide. So it's the whole period of 2 pi divided by c. Or 360 divided by c if you prefer. And that's how we're going to find our period. Yeah, I think the letter was different last year because I feel like it was 2 pi divided by b. That's what comes to mind. But again, I haven't taught that yet this year. So let's practice with example 6. Let's start with the obvious, right? Center line is -10. Amplitude is 4. Now, phase angle and period. Can't remember if they were ever set up like this. Notice how ours is set up compared to how the original form is set up. This just says 3 theta minus 135, whereas this says c times theta minus d. In order to make this match, you really need to do a factored version. I know how we did it. We did that divided by that to get the phase angle last year, didn't we? Now it's coming back to me. In order to do the phase angle last year, we did c divided by b. And we did 2 pi divided by that for your period. Sorry, I'm trying to connect how it goes together. They instead show, okay, think of this as a factored out version. So if I factor out the 3 here, it is then theta minus, and 135 divided by 3 is 45. And so how they show it in this book is that you can still see the 3 out front, but it automatically gives me the 45. And so that 45 is our phase angle. You can say 45, or you can say pi over 4. The period is still 2 pi divided by whatever's in front of theta. So 2 pi divided by, in this case, 3. Which, this one was actually listed in degrees, wasn't it? And the others were not. Based on the fact that I have a phase angle of pi over 4 and a period of 2 pi over 3, this is a good one to think degrees on. My opinion, at least. Because otherwise, graphing this gets a little difficult here. So if I think about a phase angle of 45 degrees, well, 2 pi divided by 3. If you instead think about this as 360 divided by 3, 360 divided by 3 is 120. And so you can think about a period of 120. Okay. Not the most fun, but it's what we have to work with here. So I'm going to go ahead and sketch my graph. just going to put that over there because I have a little bit bigger amplitude there. But okay, center line, -10. Amplitude of 4, which takes me up to -6 and down to -14. Now, what do we normally do? And if we want to make this realistic, I mean, technically, I guess you only have to label over to 120, don't you? But if I'm going to make this realistic, normally this whole thing is 2 pi, which 2 pi would be the same as 360. And then the middle of 360 would be 180. And so what's going to happen is my graph is going to be even smaller than that, isn't it? So let me zoom in here a little bit. In the middle of 180 is 90. I mean, I guess if you want to put the other middle over there, it's 270, but well, we have a phase angle of 45, so I'm going to break it down one more time. Okay. In the middle of 0 and 90 is 45. What's in the middle of 90 and 180? 135. Now, okay, let's see. Our phase angle is 45, which means where does our graph start? We go right 45, our graph's going to start 45. Because this is cosine, I'm going to have to start where? At the top. Now, here's the tricky part. We have a period of 120, which means if we have a period of 120, wherever we start, our ending point is going to be 120 from later. Okay? So what's 45 plus 120? 165. So 165 is where our ending point, and that is what? Between 135 and 180? I'm going to label that as 165. Because it's cosine, that means I'm going to be ending up above. Okay, so 165 is an important one to know. Probably should know your middle, yes? Where's the middle of this graph going to be? We start at 45 and we end at 165. Yes, I think so. Okay. And 105 is here a little bit past 90 before 135. So that's 105. And that's where our minimum is going to be. So we're using 45, 105, 165. If you figure out the middles there, in the middle of 45 and 105, it's going to be 75. And in the middle of 105 and 165, 135, which we already have, don't we? So we're going to cross through at 135 and 75. Tiny little graph. And the key is finding those numbers, right? Knowing enough to find those graphs, or to find those numbers. Did I go through that step by step enough? Now officially, the what? You'd be trying to find the middle of 165 and 45, so you could find the average. You could add them and divide by 2. Yeah. And actually, in all honesty, my mental math was, I guess I know that that's a distance from the edge to the middle of 60. And so if I count 30 in, that's going to give me the quarter point. So like from 45 to 105 was 60. half of 60 is 30, and so if I count in 30, 45 plus 30 puts me at 75. I kind of did it that way also. From 105 to 165 is 60. Half of 60 is 30, so 135 would be 30 in. But the original one I added and divided by 2. I don't know whoever told me that number originally. I don't know how they did it, if that's how they did it or something different, but okay. If you don't mind, I was going to skip the messing with the graphing calculator part. It says to draw the graph. It just comes down to, putting it in the calculator and then knowing how to set your settings. Like, if we want to see this graph, we can set our max at -6, our min at -14. And if we want to see from 45 to 165, we can set that. Okay. Okay. Moving on, if you will. We do have a third page here today, which is why I'm trying to make sure I keep things moving. Some important numbers. According to calculus, according to the Saxon book, 4 most important numbers. 0, 1, pi, and e. Are you familiar with all those numbers? 0 is 0. 0 is also the additive identity. It's what you add to something and get it to stay the same. 1 is the multiplicative identity. It's what you multiply by something to get it to stay the same. Pi. We know pi, yes? 3.141. Yeah. See, you guys know enough. It's a typo there. 3.14159, so on and so forth. And E, we learned E in what? Algebra 2 or pre-calc? I think Algebra 2. Maybe more pre-calc, I don't know. But the natural number, it's the base of the natural log, 2.71828. And it makes logs easier. We definitely learned in Algebra 2. I remember teaching in Algebra 2 last year, which was not you guys, but I remember teaching it. Okay, so with that in mind, let's look at some exponential functions. And when we talk exponential functions, we often talk about E. So, do you remember what the graph of an exponential function looks like?
Isn't it the curve that starts low and swoops up?
Yep. Starts low, swoops up. When it starts low, it runs officially along the x-axis. Okay, depending, assuming it hasn't been moved, but it runs along the x-axis and then curves up. It goes through 0, 1 traditionally. Okay, so exponential function means the exponent is the x is in the power, right? The variable is in the exponent. So y equals b to the x. B could be any number, including e. Sketch the graphs of y equals 1.3 to the x and y equals 4 to the x by hand. So, quick little sketches here. If we're just doing this by hand, we know the shape is like this one right here, yes? Which means a traditional exponential graph with no fancy things is always going to go through the point 0, 1. Because you put 0 into the exponent, anything raised to 0 power is uno. Now, what's another easy point to find here, especially if we're doing this by hand? Well, if I have to raise it 1.3 to some power, what's the easiest power to put in? 1. We've already put in 0. If you put in 1, what is 1.3 raised to the 1? Yeah. And so if you go over 1 up 1.3, the idea by knowing that point means you know that it's going to be a gradual up. It's not going to go as steep up as some of the others will. Okay, so it's running along the x-axis and it's graphing, but it's a more gradual up. It doesn't immediately, head straight up to the ceiling. As opposed to B. That base is bigger. How does that bigger larger base of 4 change it? X-axis, Y-axis. So if it's y equals 4 to the x, it's still going to go through 0, 1, right? And then if you put in 1, it now goes through 1, 4. And so what's true of this graph? Yeah, he's going up much quicker. Okay. The bigger that base gets, the quicker the graph goes up. Okay, so that's just, being able to understand the differences there. Now, as we look at example 9, we have E, but it's not about the E here. Okay, I mean, E is 2.718, so that gives you an idea of how quickly it goes up. But it's about the negatives. A is y equals negative e to the x. What does a negative out front of that graph do? Reflect it which way? Across the x-axis. A negative that's just on the function reflects it across the x-axis. My shortcut, and I don't know, maybe it's just how I remember it. If the negative is on the x, it's going across the y. If it's not on the x, it's going across the x. I don't know if that makes any sense at all, or if that's just only makes sense in my head. But because this negative is not on the x, it's going to reflect across the x-axis, which means, notice I didn't draw my x-axis in yet. Instead of my graph running along the top side of the x-axis and going up, it's going to run along the bottom side of the x-axis. Instead of going through 0, 1, it's going to go through 0, negative 1. And then it's shooting to the floor, through the floor. So a negative out front reflects it across the x. What's a negative in the exponent do? Reflects it across the y. So if it reflects it across the y, we're back on top. Instead of starting at the left and increasing to the right, now it's going to do just the opposite. This time, it's high on the left, low on the right. And this isn't even just about exponential graphs, folks. This is about just how do we reflect graphs in general. Being able to look at a graph. We talked the other day about, okay, remember those 12 graphs from last year? If I say x squared, you definitely know that one, right? You know what these look like. Okay, so can you picture this last one? Negative e to the negative x. It reflects where? Across both axes. So, that definitely means it's going to be down below, yes. And normally, it starts low on the left and goes up to the right. So, like in the last one we did up here on A, we started close to the x on the left and went down on the right. Now, we're going to start close on the right and go down on the right or left. Gosh. And that's going through negative 1, of course. Okay? Work to know what's what on those negatives. I know they get confusing, but work to know what's what. Okay? I actually ended up with a few extra minutes here. But on the flip side, it'd be nice to have a few minutes to talk about homework and whatnot, wouldn't it?